I'm sending you a message on Remind. There's 3. I wonder if I can tell who they are. 5. 8. Hey, let me know who you are. Bailey Frenzel. Yay! Hey, Bailey. I see you when I ride my bike. Who else is on here? Come on, 7 other people. Let me know who you are. Yay, Courtney. Hey, Sean. Hey, Viola. Hey, Keely. Oh. Yes, Mackenzie, there's only one page for 6.3. That's Algebra 2. But this one's for PreCal. I mean, you can watch it. It's what y'all did. But hey, Michael. Oh, Viola, I'm sad. I hope. When do you find out if you have to go back? Hey, Lizzie. Hey, Spencer. I miss y'all. Okay, I'm just going to start, all right? So does anybody that's on here, my parents are deciding right now my flight should be Tuesday. Is it okay for you to go back? I'm worried. I'll be praying for you and your parents. That's a hard decision. Hey, Nick. Okay, so I'm going to start working some of the problems that y'all sent in, and then if y'all want some other problems, we can work some other problems. No, I want to stay here. We want you to stay here too. I'll just be praying. That's all I can do. If I can do anything else, you tell me. I'll do it. Okay, so I'm going to start. My first question was with number 3, and they wanted to know how to find the imaginary roots. So what I did on my paper was I tried 1 and -1. 1 worked, and so then I took that 4th degree down to a 3rd degree. If you need me to work it, then send me a message and say, Miss Davis, I need you to work it. Otherwise, I'm just going to kind of talk it through. Okay? I'm good, Michael. We're good. Being cooped up here. We've only had 1 major blowout. But anyway, other than that, it's going pretty good. I'm just going to kind of talk it out. So with 1 working and giving me a 0, I use synthetic division. I need you. Okay. All right. So here's what we're going to do. I got a little whiteboard. So it is 2x to the 4th minus 7x to the third plus 19x squared. I wish y'all could talk to me. Plus 25x minus 39. Okay, so this was my beginning equation, all right? And remember, I told y'all I would do f of 1 and f of negative 1 always first because they're just so easy. When you do 1, all you do is take all the coefficients, okay? So I'm going to find f of 1. All I'm doing is looking for a 0. Now, what I would be choosing from would be my possible rational roots, which would be plus or minus. The last will be first, and the first will be last. So the factors of this guy go on the top, and the factors of this guy go on the bottom. So really, you're looking at plus or minus the factors of 39, 1 and 39. And I would do them that way. I would not go 1 and 2 is 3. I would do it that way. So 2 doesn't go into it. 3 and 13. 4 doesn't, 5 doesn't, 6, nothing else but 13. So these are the only ones. Okay, and on the bottom, you have 1 and 2. And then I told you when you write them in the blank that I will not take it this way. So don't write it like this in your blank. You have to put everything over 1. So that will be plus or minus 1 over 1, 3 over 1, 13 over 1, and 39 over 1. And then everything over 2. If this was an even number and you had ones that were divisible by 2, then you wouldn't have to list them because like if you put 4 over 2 and you already had 2, you wouldn't put that, okay? So I'm going to go 1 over 2, 3 over 2, 13 over 2, and 39 over 2, okay? So these would be the numbers that I would be picking from. I wouldn't try 4. It's not going to work, okay? I wouldn't try 6. You see what I'm saying? You're only picking from these numbers. These are the possible rational roots. All right, so I'm going to try 1 really quick. All 1 does is take all these coefficients. So because 1 raised to any power is 1, and then when you multiply it, you get that number. So 2 minus 7 plus 19 plus 25 minus 39. I always just add all the positives and then add all the negatives and see if they get to be the same number, and then they cancel each other out. One's positive and one's negative. So my positives are 2 and 19 is 21, and 21 and 25 is 46, right? And then negative 7 and negative 39 is negative 46. So this is a 0, okay? Now, if it were me, I would just go ahead and try negative 1 really quick. It might work. Here's what happens with negative 1. Anytime you raise a negative number to an odd power, it's going to be negative. So that's going to change that sign right there. Okay, so here's the deal. Even powers stay just like they are. He didn't have an X, so he can't change. Odd powers will change the sign of the coefficient. Okay, so this is an even power. He stays a 2. This is an odd power, so you change his sign, plus 7. This is an even power. Tell me if I'm going too fast. Say, slow down or something. This is an even power, so he stays the same. This is an odd power, it's to the first power, so he changes his sign, negative 25. This is a constant. You can't affect him. Okay, so thank you, Lizzie. So minus 39. All right, so I'm still going to do the same thing. I'm always just going to add up all the positives and then the negatives and see if they cancel each other out. So 2 and 7 is 9, and 9 and 19 is what, 28? That's obviously more than 28. Okay, so he's actually negative 64. So that is not equal to 0. So negative 1 doesn't work. Okay, do y'all need me to do Descartes' rule of signs? Nobody's saying yes, but I feel like I want to. Okay, so I'm going to do Descartes' rule of signs. That's what looks like this. Okay, so there's only 3 different types of roots that you could have. You could have positive roots, negative roots, and imaginary roots. Okay, so that's what this is for. Now look, This is a 4th degree polynomial, so you will have 4 roots, all right? Sometimes I put a big 4 right there. Okay, we're doing that. We're doing that. We're going to work the whole thing, okay? All right, so here's what you do. Descartes' rule of signs says, this is f of x, says that the number of sign changes that you have in f of x is the number of positive roots that you have, or lesser by an even number. So, no, Sophie, no. Becky? Come here, Sophie. I got too much help. No, Sophie, don't eat that. Sorry, Sophie's in here eating everything. So if she finds a cord, she eats it. All right. So, hey, Sophie.
They're not on.
No, it's just a YouTube live. All right. So I'm going to count the sign changes here, and then that will be my number of positive roots, and then I'll subtract 2 until I can't subtract 2 anymore. Okay? Go away, Becky. So here's 1 sign change, 2 sign changes, 3 sign changes. So there are 3. Now, once you find that number, all you do is you just subtract 2 until you can't subtract 2 anymore. Can you take 2 from 3? Yes. So I got 1. Can I take 2 from 1? No, you can't. So you stop. Okay? All right. Now, to find the number of negatives, you go to f of negative x. Y'all, that's the same skill that you used right here in f of negative 1, where you where you change the sign of the odd exponents. Okay, so f of negative x. So he's an even power, so he stays the same. He's an odd power, so you change his sign. Now listen, all it is if it's an odd power, you change its sign. That's it. It's that easy. Okay? He's an even power, so you keep his sign. He's an odd power, so I change his sign. And you can't change a constant. So now you count the sign changes in f of negative x. So positive to 1. So there's only 1. Now, can you take 2 from 1? No, you can't. All right, so here's where the hard part comes. You have to match every person in this column with every person in this column. If there were a 2 and a 0 right here, I would have to say 3, 2, 3, 0, 1, 2, 1, 0. Okay, that's the hardest part. There's only a 1. Okay, so 3's with 1 and 1's with 1. All right, imaginary roots come in pairs. That's that plus or minus that's outside of the radical. When you have a negative number underneath the radical, that plus or minus makes them come in pairs. Okay, so we know the numbers in this column will only be even numbers, 2s, 4s, 6s, 8s, things like that. Okay, now here's the deal. Every row has to add to be 4. Okay, every row that's a cross has to add to be 4. 3 and 1 make 4. I don't need any imaginary roots. Imaginaries are like fillers. They fill to make 4. Whatever you need it to be to make 4. But if you get something like a 3, you know you're wrong because it's only come in pairs. All right, so 3 and 1 make 4. I don't need any. 1 and 1 make 2. So I need 2 to make my 4. So these are my choices, okay? Sometimes I know there's a negative 1, okay? I know there is a negative 1. Now, positives, there's either 3 or there's 1. So if you find 2 positives, what do you know? There's another one because there's either 3 or there's 1, okay? So that's my Descartes' rule of signs. This is my possible rational roots right here. Okay, those were 2 things that you had to find. All right, so now solutions. Let's work on those solutions. So we found 1 right here. Okay, when we tried the 1, it gave me a 0. So I'm going to use the 1 in synthetic division. Okay, and be sure and don't use this guy. That's a common mistake, but that's f of negative x. That is not the function you were given. So be careful with this. We used it to do our Descartes rule of signs, but other than that, you don't really use it, okay? So don't go back to there. Go all the way back to here. Remember when you do synthetic division that every exponent has to be represented 4, 3, 2, 1, 0. Even the 0 has to be represented, okay? And then all you do is write the numbers down. So it goes 2, -7, 19, 25, and -39, okay? And then you always just bring this first number down, 2. Okay, you always bring the first number down, and then you multiply. What's 2 times 1? 2. And then you add, -5. And then you multiply, -5. And then you add, 14. And then you multiply, 14. Now look, what do I know my remainder is going to be? It's going to be 0, people, because that is your remainder. Okay, that is your remainder. Whatever you get when you plug it in, that's your remainder. So my remainder, I know it should be 0. So 25 and 14 make 39. Multiply, 39, and there's my 0. And these are the coefficients of 1 degree less. Okay, because this is really an x minus 1 is the factor. Okay, he's my root. So if I divided by an x minus 1, an x to the first, I would get an x to the third, an x to the second, an x to the first. Okay, so this is 1 degree less. So this becomes 2x to the 1 degree less, third, minus 5x to the second, plus 14x plus 39. Okay, now, normally I would say you're just going to be guessing. Okay, -1 didn't work. There's not anything easier. You're just going to be guessing. But people, you got a calculator, okay? I mean, I can't take your calculator. I am not going to, if we were at school, you would have a test, a 50-point test, and you would have no calculator. But I'm not going to say, don't use a calculator on your test, because here's what's going to happen. The kids that are extremely honest, they're not going to use a calculator. And then the other ones that are just, well, she'll never know, they're going to use a calculator, and that's not fair. So I'm not going to say that. So here's what I would do. If I didn't have a calculator to use, people, I would just start guessing, okay? I will say this. I know what the next one is, or I know what one of them is. I can put it in my calculator. I'll show you how I would do it in my calculator. I would go to y equals, and I would put that equation in. 2x raised to the 4th minus 7x raised to the 3rd plus 19x squared plus 25x minus 39. Okay, so I put it in my calculator. All right, now I'm going to go Zoom 6. I'm just going to graph it on a 10 by 10. Okay, and really all I'm doing, I'm kind of going by looks, but I can check it. I'll show you how to check it. Okay, so here's my +1. You can see he goes there. It looks like he only crosses 2 times. Okay, so look at my Descartes rule of signs. This is probably what I'm looking for. Okay, 1 positive, 1 negative, and 2 imaginaries. I didn't see where he crossed 3 times. It could be a triple root, but I don't think it is. All right, so I'm going to try something else. So I'm going to see about this guy right here, the -1. You should rig the camera to look down at the table so we can see your hand and your work like in class. It won't let me use my phone. Okay, that's how this all started. I was going to use my phone. And you have to have 1,000 subscribers to use your mobile device to do a live video. So I can't use my phone. I'm stuck with the computer. That's why I got the little smart board. Yeah, it's not real convenient. Tanner built me a little Elmo thing, but I haven't figured out how to do with the computer yet. I might rig something up, but I don't know. I may work on that. We'll just have to see. All right, so here we go. I'm going to try to find this negative right here. It looks like he's right in between -1 and -2. I see that 3 halves, so I'm thinking, and I'm going to choose number 1, which is a value. I could go to my T-chart and check it, except it's a fraction. It's not going to be in my T-chart. Okay, so I choose number 1, and then he says, tell me what the x is. I'm going to say -3 halves. And then when I press enter, he tells me that my y is a 0. Okay, so since he tells me that, I know he's a 0. So what am I going to do? I'm going to use synthetic division, okay? But when I do this, I'm going to show you something else about fractions. So -3 halves. Now what I'm doing is I'm taking my cubic down to a quadratic. Once you get your cubic down to a quadratic, people, I mean, you're either factoring or you're using the quadratic formula. So Nick, how do you find the imaginary roots? You have to use the quadratic formula, okay? Which is what's going to happen here. All right, so here we go. Make sure you're using these guys, okay? So 3, 2, 1, 0, they're all there. 2, -5, 14, and 39. Okay, so remember, this is how we do fractions. You divide by the bottom number, multiply by the top number, okay? Divide by the bottom, multiply by the top. So I'm going to bring this, and y'all listen, this is the way it goes with fractions. If it starts to get ugly and nasty, you just go, you don't work, okay? And you forget it. You go to the next one. You'll see it's going to all turn out beautiful. Okay, so bring down my 2. How many times does 2 go into 2? 1. What's 1 times -3? -3. And then we add -5 and -3 is -8. And then I do it again. How many times does 2 go into -8? -4. And what's -4 times -3? +12. Okay? And then I add 26. And then I do it again. How many times does 2 go into 26? 13. 13 times -3 is -39. See how pretty it is? If it starts to get ugly on a fraction, then just stop and go, well, you don't work. There's no sense working you. So this is 0. Okay? So here is my quadratic. I went from a cubic down 1 degree to a quadratic. 2x squared minus 8x plus 26. The very first thing I do is I'm going to try to factor it. But even before that, people, I'm taking a 2 out to make my life easier. So x squared minus 4x plus 13. Well, here's the problem, okay? 13, his only factors are 1 and 13. They do not add to be 4. So I'm like, he doesn't factor. So then you have to use the quadratic formula, okay? So x is equal to, there was a negative boy who was kind of iffy. He went to a radical party where there was square dancing, and he missed out on 4 awesome chicks. And it was all over at 2 a.m. Okay? A is 1, B is -4, and C is 13. I'm not working that for y'all. Okay? But that is where your imaginary roots are going to come from. And then what you have off of Descartes' rule of signs is you have this 1 positive, 1 negative, 2 imaginary roots. Okay? All right. Anybody? Let's see. That was one of the questions, 3. Then somebody had a question on 5. Okay. 5 says, determine between which consecutive integers just one right after another one. Okay. Integers are no fractions, no decimals. Are the real zeros of each function located? Just using my handy dandy calculator. Okay. So I'm going to go to y equals. I'm going to plug my equation in there. 2x raised to the 3rd minus 13x squared plus 43x minus 14. And then I'm going to graph it on a 10 by 10. That looks really bad. It is a cubic equation. Okay, so I'm thinking he probably just crosses at one time. All right, so I'm going to zoom in for you just in case you need help doing that. So I'm going to press the zoom button, and then I'm going to choose zoom to, which is zoom in. You still have not zoomed in any, but there is a plus sign. It's normally pops up if you haven't used your calculator or reset it in a while at 0, 0, but I'll show you a picture of it. Okay, can you see it? There it is. So I would put it wherever you want to zoom into. So I want to zoom in and see where this is crossing right here. So I'm going to put my little plus sign over there by it. Okay, and then I press enter and it zooms into that area. Okay, now what I can see is I can see that this crosses in between 0 and 1. Now I use my graph to kind of cheat like that. So, but then I get my information from my T-chart. So I'm going to go to my T-chart, second, and table. And all I'm looking for is where do your Y's, that's really hard to see. Where do your Y's change signs? Because if your Y goes from a negative to a positive, it had to have crossed 0 before it does that. Or if it goes from a positive to a negative, it had to go through 0. And 0 is on that x-axis. Okay? So I can see, we thought it was between 0 and 1. So then I set my table to look back to that. Okay? And I can see, I can't do this backwards. I can see right here that it went from a positive to a negative. Okay, or from a negative to a positive. From 0 to 1, it went from negative 14 to positive 18. So if it went from a negative to a positive, it had to have crossed 0. So your answer for that one would, there's only one. It is an interval, and it's an open interval. So you're not including anything. So it would just be from 0 to 1. Okay, just from 0 to 1. That's a 5, y'all. Sorry. So that's number 5. That's the only answer that one has. If it crossed multiple times, I would look on my graph and see between what 2 integers it crossed, and then I would go back and I would look at my table and say between 2 and 3, is there a sign change? Every time you have a sign change, then there is a 0 located between that. Okay? All right, the next one someone wanted was 13. Number 13 says use synthetic division to find G of 3. All you're going to do is do synthetic division like this, okay? But you always put the root out here. So the 3, he may not be a root, okay? But if he is a root, you know you'll get 0 for your remainder. If you don't get 0, this is what you get if you plugged it in. See, up here we plugged it in and we got 0, okay? So here's what they want you to do on number 13. So, number 13. Now, the only thing, remember about synthetic division is you have to make sure that every exponent is there, okay? So, while I'm looking at my problem, let me find it. Okay, while I'm looking at my problem, all I'm going to do is count and make sure it goes 6, 5. Oh, there's not a 5. So I'll put a 0 in between there. 4, 3. Oh, there's not a 3. So I'll put a 0 in between there. 2, there's not a 1. Put a 0 in and then the 2. Okay, so in my synthetic division, I should have a 3 out here. Okay, and then you'll have a 1. That's for the x to the 6th. There was not an x to the 5th, so you have to put a 0 there. There is an x to the 4th. It's -4. There's not an x to the 3rd, so I'll put a 0. There is an x squared, so I'll put a 3. There's not an x to the 1st, so I'll put a 0. So they're really testing to see if you know this skill, okay? And then your 2 goes there, okay? And then all you're going to do is synthetic division. This number that you get right here, that's your remainder. That's what you would get if you plugged 3 in. And that's all they want. They want you to show them this. and they don't care anything about except this right here. And when you first learned synthetic division in Algebra 2, we called it synthetic substitution, because if you substituted this in the polynomial, that's what you get, okay? And then later on, we learned how to use it like we use it right now, okay? So that's 13. Let's look at 21. Okay, 21 looks like this. Minus the square root of 2 over 2 plus the square root of 2 over 2i. Okay, so this is what it looks like. What does a minus sign outside parentheses mean? So we are supposed to get a big number for that last guy. Yeah, it's pretty big. It's above 400. Between 400 and 500. Yes, it means distribute the negative. So you're going to change everybody's sign over here. So I'm going to take all the parentheses away because I won't need them anymore. So I'll have square root of 2 over 2 minus the square root of 2 over 2i. And then the opposite of a positive is a negative square root of 2 over 2. And the opposite of a positive is a negative square root of 2 over 2i. Okay? Now, what you do is you collect the real parts together and you collect the imaginary parts together. Okay? I'm trying to get the top off this. All right. So the real parts, these are the real parts right here. Okay? So the square root of 2 minus the square root of 2 over 2 minus the square root of 2 over 2 is what? 0. Those cancel each other out. All right? I can't see the green very good. And this is a negative square root of 2i over 2 minus the square root of 2 over 2i. So if you owe one square root of 2 and then you owe somebody else another square root of 2, then you owe 2 square roots of 2 over 2i. Okay? So this is my answer right here. What's wrong with it? What do you need to do to it? What? I think. Okay, so the 2's, remember, good night. Remember that if, remember if those outside can play together. So Lizzie said simplify. Yes, so these 2's cancel. They're both outside, okay? So those outside the house can play together and those inside the house can play together. And he's the only guy inside. So they must not have the coronavirus because people are outside. So these cancel out and you get negative square root of 2. And make sure that you put that I away from that radical. I'm even okay if you write it like that. Negative I square root of 2. Okay? All right, let me see. What's the next one? 13. 21. That is 21. 29. Now, look. I hesitate to tell y'all this, but really I'm working on your college skills, evidently, because it's looking like some high school skills are going by the wayside. All right, so let's do 29. Okay, so here is 29. He looks like this. 3 plus 2i over 5 plus I. Okay, so this is what he looks like. You can't reduce anything, y'all. Even if this was a 6, be careful and don't slash these guys and go, oh, he's a 1 and he's a 2. No, he's not. If you can't take it out of everybody, you can't take it out of anybody. Okay, so be very careful, like just slashing stuff. But here's the problem: you can't have an I in the denominator because it actually represents a radical. Okay, the square root of negative 1. So you have to multiply by, now if you watch the videos, you know you have to multiply by the conjugate. And the conjugate of 5 plus I is 5 minus I. Now, the cool thing about conjugates is when you multiply conjugates, the middle terms go away. Okay, so this plus 5i and this minus 5i, you're just foiling it. But they go away. And so all you actually get is square the first minus square the last. If it has an I, it ends up being plus square the last number. But for those of you that can do that, just do that. For those of you that are still struggling, then do it like this. Okay, conjugates you should know. Square the first, 25, minus square the last. I times I is I squared. Can you have an I squared? No. I squared is -1. So this becomes 25 minus a -1. Okay, and that becomes 25 plus 1 is 26. So now I know my denominator is 26. Oh, sorry. Okay, so now I'm just going to fold the top. All right, so when I fold the top, I go first times first. What's 3 times 5? 15. And the outers give you a minus 3i. And the inners give you a plus 10i. So there is my plus 7i. Okay, last times last. Positive 2i and negative 1i make negative 2i squared. Okay, now remember, you cannot have an I squared. Okay, and I'm going to tell you this too. Be very careful just making that a plus sign or something. I don't do that because I see that that's a big careless mistake. Okay, so I'm just going to, this I squared is -1. All he does is change this guy's sign. So I'm just going to cross the whole thing out and rewrite it as a plus 2. What's 15 plus 2? 17 plus 7i over 26. Okay, now let me see what y'all are saying. Is it okay if we get numbers that are off the graphs on problems like 1 and 2? Yes, if you get a number that's off a graph, like if you have a graph like this and you have a number that's down here and it's like 3 -42, then just put a dot down here and go 3 -42. And I'm like, oh, okay. All right. Okay, so once you get this answer, here's what you want to always do. Look at all the numbers. If all the numbers will reduce by something, then you reduce it. If 2 of them will reduce, you better leave it alone. Okay? If all the numbers will reduce by something, then you should reduce. Okay? And y'all look, there is an I on your calculator. Okay? That's not exactly how I wanted you to do these problems, but it is a good way to check. Okay? And I mean, right now we're just doing worksheets. I'm not worried about a test. Okay? I can't monitor a test. I may do some adjusting on my worksheets. I may do some adjusting on what I grade. And the reason is because I spent 6 hours yesterday grading papers. I only cried 3 times. But that stupid thing that we have to grade it with in that Teams, every time, like when you put them in, there's 3 pages. Then when I go and click one page, it pulls it up. Then when I go out of that to click on another page, it pushes me out of the whole system. And so then I have to go back and get in and then get to it, it's just crazy. And so I was frustrated and not very happy. But anyway, so I may have to adjust a little bit on that. So I don't know. I'll just have to see. But I will say this. Some of the kids uploaded, I don't know how they did it. Maybe they can tell me. But they uploaded theirs, and it was all on one link. You know what I mean? It wasn't like one page, the way I did it to y'all. It wasn't like one page and then another page and then another page. And I know that if you need to upload a PDF, that you can go, if you have an iPhone, I learned this, getting kind of tech savvy, okay? I learned that if you have an iPhone, if you go to your notes right here and you actually open up a note, do a new note, then you go to the camera and you take a picture, that it'll change it into a PDF, and then it's easier and you can do it that way, okay? I'm checking my Remind to see. to see what I got. Okay. Okay. So is there another one? 31. 31, look, on 31, this is what 31 looks like. Is this so bright that y'all can't see it? It's very bright. I can't hardly see it when it's on the screen. Okay, so on 31, what I would do is I would just distribute. Here you're going to distribute a -3i. Here you're going to, and you know what I would do right now? I would change this. What is that? An I squared? You can't have an I squared, guys. Change it right now. I mean, start fixing the problems at the beginning. So what is I squared? -1. Then I'd substitute -1 in for this, and I would distribute a -1. Everywhere you get an I that's any power other than 1, you have to change it, okay? You can only have I's in your answer. You can't have I squareds, you can't have I cubes, you can't have I fours, okay? If you didn't pay attention to the video, okay, this is what, this was the little way I told y'all to memorize them really easy, all right? So here it is. It goes like this. It goes, I won, I won. Keep your negative stuff on the inside because nobody wants to see it, okay? And here's what it is. This is an I to the first, obviously. This is an I squared. This is an I cubed. And this is an I to the fourth. Okay, it's just kind of an easy way. You usually don't get anything more than a fourth, but you know, it's just an easy way to remember it. I won, and then keep your negative stuff on the inside. Nobody wants to see it, especially now. We're all trying to be positive. Okay, all right. So, anybody else got a question? Because we've been on here for 45 minutes. And I do miss y'all though. So here's what I want to know. Would y'all like to do this before every review? Because that's what we're going to do. So on 29, do we keep it like you had it on the board? Yes. On 29, this is my answer. So, Sophie, if this were a 16 and an 8, I would reduce everybody by 2. Okay? But it's not. It's a 17, a 7, and a 26, and nothing goes into all those numbers evenly, so you're stuck with an answer. You can, now look, you can write it like this. I'm okay for you writing it this way. This is the way I write it just because it's easier for me to grade. But if it actually said, if you were taking the SAT test or something like that, and it said put your answer in standard form, your answer would look like this. It would look like that because that's in the A plus BI form. Okay, so just so you know that if it was that, 9 through 12 is confusing to me. Oh, that's just seeing if you know your transformation skills on 9 through 12. Okay, so I mean, obviously you have a calculator, but you shouldn't. You can use your calculator and tell, like. Look, like this x to the third minus 1, all that's going to do is take that cubic equation, okay, and he's going to move him down 1, all right? So is he going to have rational or irrational zeros? His rational zeros, he has 0 rational zeros and 1 irrational zeros. That would mean 2 were probably imaginary. Obviously, he only crosses the x-axis 1 time, so the other 2 have to be imaginary. Do you see what I'm saying? So I'm going to, but I don't know if graph that on your calculator, okay? I'm going to say it has 1 rational. I'm going to say it's going to be one of these. Ooh, wait a minute. It could be either this one or it could be this one down here. You just need to use your calculator, okay? Use your calculator and it'll help you. Those weren't meant to do without your calculator. The first ones on the papers were meant to do without your calculator, but you don't have to. You're going to have a calculator. You're not taking a test. I wouldn't even give a big test with no calculator. That's why I always give you a 50-point test and say, all right, you got one problem. You have to do all these things to it. You can't use a calculator. And then I, kind of make you know how to do it. And then I go, use your calculator on your big. This before every review, the day before it's due. Do you want to do it 2 days before it's due? I know y'all's reviews are kind of long. Is there an app I can use to substitute for a graphing calculator since I don't have one? Yes, there is. Courtney, are you on Remind? The day before is good. The difference between an irrational and a rational number is an irrational number has a square root in it. No, but I can join. Okay, you should join Remind. I'm going to tell you how to do it right now. You take your phone and you text 81010, and I took a picture of the board. I think y'all's is BG Davis. Yeah, you go 8. The number that you're gonna text to is 81010, and then you're gonna say what you're gonna reply is at BG Davis. Okay, at BG Davis, and I will. If you'll do that, I will send you. A way that you can use your phone as a calculator. Okay, because right now TI is offering a whole bunch of stuff. If one of y'all know how, you could tell me now, but I can look it up. But TI is offering a whole bunch of stuff that you can, where they're offering free apps and things like that you can do on your phones for all the kids that are at home learning and don't have a calculator. So that answers that. All right, Bailey, you good? Everybody good? Okay, so probably what I'll do is I'll assign your lessons on Monday, and we'll have worksheets due on Fridays. Okay. Your battery is running low. Okay. All right, so I'm going to go, okay? Y'all have a good day and have a good weekend. Don't forget to submit your worksheets. If you could submit them on one file, in other words, I don't have to go back and do that, then that's very much appreciated. If you can't, it's okay. We'll be okay. Thank you, Nick. If you haven't liked or subscribed, do so now. So thank you very much. All right. I love y'all. I miss y'all. And I hope y'all have a wonderful weekend. And just relax. We're going to all get pretty good at this. I miss you too, Bailey. Okay? The sooner we can get this done and over with, the sooner maybe we'll get back to school. All right? Y'all have a good weekend. Bye.
And it's still just going to make my fridge. Yeah, mine's not. Yeah.